Good morning, boys. Today we are going to focus on finding a missing part of a ratio, just like in the previous lesson. But today we are including reciprocals and decimals, okay? Reciprocals. Sometimes the unknown part of the ratio is one of the denominators and not one of the numerators, just like we did in the previous lesson, because in the previous lesson it was either one of the numerators. Today we are going to deal with the denominators as well. Alright? For example, find the unknown part of the ratio in the first example. 6 is to 4 equals 18 is to 8. Now, as we said and explained in the previous lesson, okay, we can write these equivalent ratios as fractions, okay? So I'm going to write is 6 all over 4, okay, is equal to 18 all over a. So the first step is to write them as equivalent fractions, okay? Now, the unknown a is in the denominator, okay? Now, to solve such examples when the unknown is in the denominator, there are sort of two methods. One method is using the reciprocal method, okay? And you know the reciprocal, we did it in fractions, okay? When we do the reciprocal, when we flip the numerator with the denominator, right? We change with the numerator with the denominator. And then there is the cross multiplication method, which we've been using in the previous lesson, right? I'm going to use them both, okay? But then I'm going to focus on the cross multiplication method since we've started it in the previous lesson. So we can continue using it, because even when the unknown is in the denominator, we can use the cross multiplication method, okay? Let's start with the reciprocal method. Now, if two ratios are equal, alright, then the reciprocals must also be equal, alright? If two ratios are equal, then the reciprocals must also be equal. So we must still put down the equal sign, okay? So in the image below, we have a all over b is equal to c all over d. The fractions are given, the ratios are written like this, alright? A all over b is equal to c all over d. A fraction is equal to another fraction, right? If we do the reciprocal of a all over b, remember that in the reciprocal, the numerator and the denominator changes position, alright? The numerator goes down as the denominator and the denominator goes up as the numerator. So instead of a all over b, the reciprocal of a all over b is b all over a, alright? And the reciprocal of c all over d is d all over c, right? So, if we left the fractions as 6 all over 4 is equal to 18 all over 8, and I've written it down again, then reciprocal of each fraction would be the 6 will go down, the 4 will, as a denominator, the 4 will become a numerator. 18 all over a, the 18 will go down as a denominator and the a will go up as a numerator. Now, from then on, we can use the cross multiplication method. So I'm going to multiply the 4 with the 18 and the 6 with the a, alright? So that it becomes 4 times 18 is equal to 6 times a, alright? Now, 18 times 4, 8 4s are 32. 1 4 is 4 and 3 is 7. So 72. 6 times a, it's 6a. Now, I need to obtain a on its own, alright? So, 72 division by 6 is equal to 6 times a division by 6. I can cancel the 6 with the 72 on the left. 6 into 72 goes 12. I can cancel the 6 with the 6, right? So the answer would be 12 all over 1 is 12. 1 times a all over 1, it's a. A is equal to 12. So the unknown is a, alright? Now, so that's the reciprocal method, alright? We had to do reciprocal first and then we had to use the cross multiplication method, okay? So instead of doing all this, okay, I'm going to use the cross multiplication method immediately and see what happens. So, I'm going to use the cross multiplication immediately. So, 6 times a and 4 times 18. Okay? So, 6 times a is 6. On the left, I would have 6 times a equals. On the right, I would have 4 times 18. Okay? 6 times a, it's 6a, right, is equal to 18 times 4, it's 72. So what happened is, instead of obtaining a 6a on the right, I've obtained a 6a on the left. And instead of obtaining a 72 on the left, I've obtained now a 72 on the right. Okay, so it's the same, all right? In the cross multiplication method, I have one less step than the reciprocal method, because in the reciprocal method eventually I still have to use the cross multiplication method. So I'm going to solve the equation. 6 times a is equal to 72, so I have to divide both sides by 6. So the 6 into 6 goes 1, the 6 into 72 goes 12, so it's a equals 12 division by 1, it's 12. Okay, so the answer is a is equal to 12, just like with the previous method. Now, in example 2, okay, first of all, our lesson, apart from involving reciprocals and involving unknowns in the denominator, it involves decimals as well, all right? So we're going now to work an example with one part. We can have more, but with a part of the ratio which is written in decimal form, all right? As a decimal number. So example 2 is find b when 4.5 is to 15 is equal to 12 is to b. Now, when we have a decimal part in one of the ratios or in more, all right, first of all, we have to convert all parts of that particular ratio, not the others, all right, that particular ratio which has a decimal number in it, all right, and we have to convert that particular ratio to whole all that particular ratio, because the ratio has two parts, all right, we have to convert all that particular ratio to whole numbers first. So in our case, right, 4.5 is to 15 is equal to 12 is to b. Only the first ratio has a decimal number. I'm referring to 4.5 is to 15. Only that part has a decimal number. The other part, 12 is to b, has a whole number only. Alright, so I'm going to leave that for now. Okay, I'm going to deal first with 4.5 is to 15. Now we're going to remember, all right, to when we did simplifying ratios. When we did simplifying ratios involving decimals, we had a decimal, all right, we had to multiply by the number of decimal places that the number has, all right. So 4.5 in this case, 4.5 has one decimal place, all right. 15 is a whole number, alright, so I have only 4.5 as a decimal number. 4.5 has one decimal place, so I have to multiply by 10. But I have to multiply by 10 both, all the parts of that ratio. So I have to multiply by 10 the 4.5 and also the 15, all right? So 4.5 times 10, all right? When I multiply by 10, the point moves one place to the right. So it becomes 4.5 times 10. I move the point one place to the right, it becomes 45 is to 15 times 10, 150. Okay? I can cancel the ratio so that I won't work with large numbers. Okay? It can be cancelled with 15. 45 division by 15 is 3. Okay? And 150 division by 15 is 10. Right? So we've removed the decimal number, all right? We've converted it into a whole number by multiplying all the parts of that ratio of the first ratio by 10. Okay? I've multiplied the 4.5 by 10 and the 15 by 10. It became 45 is to 150, right? And we simplified it into 3 is to 10. Okay? We can work with the 45 is to 150, or we can work with the 3 is to 10. I'm going to show you both, all right? Now, if I work with the 45 is to 150 is equal to 12 is to b, all right? I end up with, I write that as a fraction first, so 45 is to 150, e all over 150 equals 12 all over b. I'm going to cross multiply. (45) times b, it's 45b. 15 times 12, all right? 15 times 12 now. 15 times 10, it's 150. 150, 15 times 10, it's 150. 15 times 2, it's 30. So 150 and 30, it's 180. Okay, 180 and another 0, because 150 has another 0, it's 1800. Okay. I split the 12 into 10 and 2. 15 times 10, it's 150. 15 times 2, it's 30. So 150 plus 30, it's 180. And then I added another 0. Now, 45b means 45 times b is equal to 1800. Right? And I'm going to divide both sides by 45. 45 into 45 goes 1. 45 into 180, all right, goes 4. And then 45 into 0 goes 0. So b is equal to 40. I'm going to show you that it's better to work with smaller numbers. Now, if I use, all right, the 3 is to 10 instead of the 45 is to 150, it would be better, all right, to work with smaller numbers. So I'm going to work with 3, or, all right, I'm going to use this method, the smaller numbers. 3 is to 10 is to 12 equals, 12 is to b. I'm going to write them down as a fraction. 3 all over 10 is equal to 12 all over b. I'm going to cross multiply. If I cross multiply, I end up with 3 times b, it's 3b. 10 times 12, it's 120. Alright. 3b means 3 times b is equal to 120. I'm going to divide both sides by 3. 3 into 3 goes 1. 3 into 120 goes 40. Look how easier it became. So the answer is B. 1 times B all over 1, it's B. B all over 40. Division by 1, it's 40. Okay? So, I ended up with the same number, but with less working, obviously. So it's better to work with a simplified version of the given of a particular ratio. Example 3. Now, we have another decimal number. Find A when 0.24 is to 12 equals 2 is to A. So, first of all, I'm going to deal with the decimal part. So I'm going to deal with 0.24 is to 12. I have 2 decimal places over there. So I need to multiply by hundreds. So 0.24 times 100 is 2, and I need to multiply the 12 by 100 as well. 1, 2. So 1, 2. Okay. So 0.24 times 100, I move the point 2 places to the right, it becomes 24 is to 12 times 100, it is 1200. So now I write the ratio as this. 24 is to 1200, okay, is equal to 2 is to A. I write those as a fraction. 24 all over 1200 is equal to 2 all over A. I cross multiply. It becomes 24 times A is equal to 2 times 1200. 24 times A, 24A is equal to 2400. 12 times 2, 24, and I add two zeros. 24 times A, to remove that times 24, we need to divide both sides by 24. I can cancel the 24 with the 24. I can cancel the 24 with the 24, and 24 into 0, and then the other 0 goes 0. So A is 200. Okay. Mela. So A is 200. So when we have 2 decimal places, alright, we need to multiply by 100 all the parts of that ratio, alright, and then we continue, because in the other part of the ratio we do not have any decimal numbers, okay? So we ended up with the unknown A is equal to 100. If you need to check, right? 0.24 is to 12, it became 24 is to 1200. So 24 is to 1200. If I simplify it, if I need to check, let's write it down. let's write it down as a check. If I need to check 24 all over 1200 is equal to, should be equal, both sides should be equal to 2 all over A. We said it's 100, so I'm going to substitute 8 by 100. Okay, 24 into 120 goes 24 into 120 goes 5. 24 into 0 goes 0. I can simplify the other side. 2 into 2 goes 1, 2 into 100 goes 50. So I ended up with 1 all over 50 is equal to 1 all over 50. Since the left hand side is equal to the right hand side, then my answer is correct. Alright? You can check it like that. When you see, especially when you see large numbers, it's better to check. Alright? Now, the homework is going to be similar to these examples, boys. Just in case you get stuck in the homework, please pause the video, alright? Watch the video again, pause in the examples, work them again on your own. If you manage to work them on your own, then you can carry on with the homework, okay? So, that's all for today, boys. Good day and take care.